So we have a very simple GraphQL server at auction. It serves all our front ends, mobile web, everything. And our clients talk very little outside of the GraphQL that they do. We have some plain HTTP endpoints left from before the time that we had Graph. And so I'm going to be talking about how we improve memory usage of this graph, especially in the subscriptions. We have our GraphQL service is split in two using one code base. So we have like a service that serves only subscriptions, only WebSocket, and we have another one running off the same code base that serves request response. And so I'm mostly going to concentrate on the subscription side, but obviously some of this stuff applies to both. So this was the problem. Reached heap limit, allocation failed, JavaScript heap out of memory. That's a wonderful message coming straight from V8 telling Node to die. And so we were getting a lot of this, a lot of server restarts. And so this is where the quest started. So yeah, what do we have? Our setup is that these servers, they subscribe to Kafka topics and use GraphQL subscription Redis for PubSub. And so on my Mac, I tested this, the memory usage locally, and I did exactly that. I ran Kafka locally, I ran a server locally, and I connected 4,000 WebSockets to it, and just ran kcat and flooded the server with messages and saw what got through and what didn't get through. Pretty simple setup. So this was the baseline. In what is 250 seconds? That's, what is that, like 2.5 minutes or so? No, that's more. That's four and a half minutes, right? In 4.5 minutes, I was able to deliver 16 Kafka messages. Count them, 16 golden messages went through. So not that great. You can see the memory usage. It's kind of like, it goes up, and then I delivered the message, and it goes up, and then I delivered the message, right? So it was really, really struggling there. So, okay, what can we do, right, to improve this situation? Well, the first thing is the context. Every time you run a GraphQL execution on Node, there's a context, right? And I realized that we tack on a lot of things on the context that we just simply weren't using in our subscriptions, because our subscriptions just take the Kafka message and they send it on as a GraphQL query response. So they make very few backend requests. And so we have all these backend definitions hanging on the context that say, like, let's say, I don't know, geography. So like context.backends.geography.post, and then context.backends.this and that, right? But we're not using any of that. So long story short, just make it all lazy. Use this wonderful thing called the proxy and just redefine all these as proxy targets. And so you only create the actual backend when you need it. And this thing didn't need any of them, so all of a sudden we saved all of these things times the number of concurrent executions on GraphQL. So yay. And the best part of it is we didn't have to change any of the code except the implementation. Anybody who used the backend didn't even know that they were lazy now. So it was completely transparent. So that was really cool. And as you can see, our memory usage did improve. I'm going to keep comparing everything to the original. So the numbers are good, but they're not that good. The most important thing you'll notice here is when it's idle plus 4,000 connected sockets, even though there is zero traffic, the sockets are already there. You can see this plateau is a lot lower because all those contexts are now a lot slimmer, right? So okay, our performance didn't really improve, but at least our memory usage went down. So, die less often. And, the performance penalty wasn't that great. I mean, on my laptop, it was within error, basically. Okay, so then we have this thing where we take the Kafka message and we convert the keys to snake keys, right? Because we have one convention on Graph and we have another convention on Kafka, and so we have to do this. And that's all it does. And what we had was this really old style JavaScript code using Lodash, which was great during its time, but we now have the engine doing a lot of the lifting. And so So I replaced some of that in like a first pass with some more modern iterators. And the result was that the memory usage kind of, it kind of went back, but you can see that the plateau here is still lower. So that context stuff still helped. And whew, we're back in the green now relative to the beginning. So that's positive. And so what was the next thing we did? OK, well, this thing. I mean, I told you at the beginning, we use GraphQL Redis subscriptions to make sure that everybody gets only the messages that they need. And this is just an illustration of how it works. Like we have all our graphs in a single consumer group. So basically, the Kafka messages get divided between the instances. And so Redis needs to sort of reconcile that. Because if somebody's subscribed on an instance that it doesn't get the message, they still need to get the message. So that's why we use this. And so I figured, OK, well, what if I upgrade it? Is that going to improve memory? Is that going to improve performance? Is it going to do anything? Well, it did a little bit. Memory, not so much, again. So it was kind of a miss. But at least performance went up, yay. So we're now up by 1/4x versus the original. So yeah, why not? OK, so then next step. You know, our what do you call that? The Kafka, the schema. Right? It doesn't change, right? I mean, we are a business. We have things like listings, and we have things like users, and we have things like properties and that kind of stuff. And properties are called property. They have a property ID. Their listings have listing ID. Those words, listing ID, property ID, they don't change, right? So why do we keep computing the snake case for a listing ID 59,000 times, right? Doesn't make sense. Let's just memorize it. So that's what this does, and lo and behold, performance went from up 28% to like 3x. Memory usage still not so much, unfortunately, but at least the performance. You can see now that the heaves and hoes of the engine are a lot smaller. The heaves are smaller and the hoes are smaller too, right? And so now it's starting to look like a flat line, as if it's doing something instead of just like hiccuping all the time. So that was a pretty good improvement. Then, since the memory usage is still what it is, I figured, OK, so let's do HPA. Because we at this point, we weren't even doing HPA. It was this many instances. They died. We replace them. And so we had to key the HPA on the memory usage, which in itself was an interesting exercise. And there's an additional problem, which is that we had a leak for long-running instances. And so HPA didn't help there, because the way HPA works is, ideally, what you'd want is it removes the oldest instance and it replaces it by one or more newer ones. Or if it scales up, then when it scales down, it gets rid of the old ones, not the new ones. But that's not Kubernetes. That's just not how it works. So we're like, OK, whatever. just kill them every night when nobody's watching anyway. And so that kind of kept things in balance. But hey, whatever, right? Our clients are written quite aggressively. They reconnect in a couple of seconds. So people ain't going to miss much, especially at 2 a.m. If you're up at 2 a.m. watching whether somebody places a bid on the property you want to buy, then you are really, really dedicated, and I applaud your efforts. But you are in the minority, way in the minority. Anyway, so the other thing I figured is, OK, let's see, what if we give the engine more things to work with, right? Because us being sort of semi-front end, back end, what with the GraphQL and all, and especially the GraphQL on Node.js and all, we have these like steps where you compile the TypeScript down to JavaScript, and then you bundle it all, and you end up creating JavaScript that's like lowest common denominator for the browsers that you want. And I looked at the JavaScript it was outputting, and I was like, var? Are you kidding me? And this function called __async and ___ awaiter. This is the 21st century, Let's work with Node 20, which is what we have, not like IE6, right? So I was like, OK, let's make a special case for the server, produce Node.js 20 code, and let's see how much did we gain? Is this Okay, there we go. We went from 3.3 to 3.6x, just by letting the engine do what it does best, right? And by the way, the code, if you were to turn off maps, is actually more legible now. So yay, double yay. All right, but still, again, with the memory usage, right? Let's get back on topic here, right? So then, let's see, what's the next thing we did? Oh, yes. Okay, I figured if we have fewer temporary objects, what would the map and all that? Map creates temporary arrays, et cetera, and then it deletes the old array. What if we just looped in place and it just modified the arrays that we have, right? In that convert object to snakes keys that I was showing you earlier. And so I replaced it with just for loops. Like the array, you can just mutate because the keys don't matter. The objects you can't mutate because if you change the keys, then it's really awkward to just insert a new key, remove the old key, and use the same. It's much easier to just create a new object and just put all the snake keys in the new object. So you can't do away with temporary objects, but you can do away with temporary arrays. And lo and behold, we went from 3.6x to like 6.3x. And now this curve here is starting to really, really be nice and smooth, right? But again, with the lack of memory improvements, right? Hence the name of the talk, in memory of Travails. These were Travails. They were not slam dunks by any length. So then, first candidate. This tool is great. I love it. This is called the heap profiler, right? No, sorry, heap snapshot tool in DevTools. You can use it with Node.js. You run the code to a point, you get a heap snapshot, then you change the code. Like, for example, you run it completely idle, you take a heap snapshot, then you attach 4,000 sockets, no traffic, just 4,000 sockets, you take another heap snapshot. And it'll tell you, like, there were this many objects of this kind created and this many objects of this kind destroyed, right, between the two heap snapshots. And so if you have like a plus 400,000 thing, you're like, do we really need those? But at least it tells you what, it makes you think about what are the things that you might not need. Whereas if you just look at the code base, you're just guessing, right? At least it tells you. You're making 400,000, in this case, location nodes in your AST. I don't care if this is line 5 or line 12, right? By this time, I have parsed the AST, and I just want to execute it. I'm not a debugging tool, I'm an execution tool, right? So let's get rid of all these location nodes, right? So the things that I'm talking about are this. So you can compile the AST and you can give it this option of no location, right? So whenever a query comes in, it turns that string that comes in into a tree, right, an AST. And you can say like no location, true. And all of a sudden, the AST is 1,000 times smaller because you don't have all those excessive nodes that you're never going to use anyway, right? So then, this is what happened. Boop, boop. Oh, sorry. That stupid thing keeps rolling down here. Okay, there. And there we go. See? It went down a little bit because of all those location things. All right, so next step. Can we reduce the context some more? Where we're making a little bit of progress. Okay, so we have these data loaders, which are data loader objects, but we wrap them a little bit because they're like purpose-made and so forth. And they have some parameters hard-coded and other parameters come in at runtime during the query. And so, we also create all possible data loaders for all possible backends for every single context, whether it's going to use them or not, right? And so, okay, repeat the story. Let's make them lazy. And I did. And if you can imagine a ternary with like 35 different cases, then please don't, because your mind is just going to not continue to work. So just don't go there. I actually put that up in a PR, and the guy reviewing it is like, nope, just no. We're never going to maintain this. And I'm like, okay, all right, fine. Let's try to think of something. We have this object that says property 1 function called function call, property 2 function call, property 3 function call. And what am I doing? I'm turning this into a ternary, right? So why don't we do that when we do all those steps of like, converting from TypeScript to JavaScript, converting from JavaScript to JavaScript? we use Babel there, right? So just put a plugin in there and just, give it a little hint, like, dude, I want this to be lazy. And that's exactly what we did. We created this fictitious web API called proxy.lazy, which of course doesn't exist anywhere. But we also wrote the plugin to actually make Babel understand that and turn it into JavaScript that does exist. And so basically what it does is it takes an object literal, and it has to be a literal. You can't pass it a variable because we're actually parsing the AST for the JavaScript. So it takes this literal and basically turns it into just the ternary that I described. And so we're doing what I wanted, but we're doing it behind people's backs. And so they can keep their nice looking code and get the performance of it being lazy. So what did we gain there? Let's see. Why did I jump to this slide? I said that. OK, now I'm confused. Yes, we did this. Oh, yeah, right, the AST query cache. That's another thing we did. So, suffice it to say, the subscriptions, they don't go through Apollo server, so they don't actually have a query cache. They go straight to like GraphQL subscriptions WS or something like that. We use that old one because we have a hack on the protocol for keep alive purposes, and so we can't really switch to the new one, long story short. So we're using it, and it's working for us, so there you go. And so we added a query cache, and yeah, so we needed to monkey patch two things. The parse, in it comes, but if it's already parsed, don't parse it. You need to take the SHA-256, which in the request response case is kind of redundant because Apollo is going to do the same thing, but small price to pay. And besides, the request response side is not the one with the memory problems, and it performs just fine with an extra SHA-256 computation. It's not going to kill anybody. So then we look up the AST. If we find it, good. Oh, and by the way, GraphQL JIT, that's another one that helped out in this case. I found that GraphQL JIT is good for like queries that are not too small. If the query is too small, I found that it doesn't help that much. Like if you just want 3 fields, then just do it the regular way. But if you have a giant query, then it can take quite an edge off. And so hence the compilation artifact creation here. And of course, in execute, you want to do as little as possible. You want to pre-compute as much as possible because execute is extremely, extremely hot. So you don't want to start computing compilation artifacts and doing all kinds of fancy stuff in execute. In execute, you execute. You don't do anything else because every nanosecond counts. And so that's why I said it must be as lean as possible. So all you do is you just retrieve the compilation artifact. You found it, good, use it. If not, just do what you would have done anyway, which is just execute GraphQL. So, okay, now let's try to see what happened. After we did all that, that's this slide. And the previous one, there you go. A little bit of a reduction again, right? Look how nice the plateau is over here. It's just getting really lean here. So that's some good news there. All right, so let's see. OK, we've done other stuff since then, tried to stabilize it some more. I'm looking at maybe using in-memory pub/sub instead of Redis pub/sub. It's like, so far I'm only seeing about like a 17% improvement. And it comes with risks because obviously Redis pub/sub is well tested. But on the other hand, I think our server can handle having each pod in its own consumer group so that each pod can handle all messages because it might have to, right? If it happens to have like a Christmas tree subscription, I want everything all the time because that's what the user said, then it's going to have to handle that anyway, right? So anyway, I can still take a look at see if we can shave off any more objects off the context. Doing things while there's traffic, taking a heap diff while there's traffic is a lot harder because there's so many temporary objects coming and going that you're going to get a lot of noise. And it's hard to tell, like, is this something that happens often or not? Because it's quite noisy. And so it's not as clean as when you just have idle without sockets versus idle with sockets. That's a pretty clean distinction. Promises, we don't use that many, but we still use some. We had a situation on the other side that's sort of beyond the scope here, where we had like tons of promises that were being used because we were like await something, and that something ends up being like the number 5. You know, and whenever you await something that's not a promise, you're buying into a lot of pain because evaluating a promise tacks onto your execution stack. And so instead of going back to the event loop and helping somebody else with their request, it comes back to you and then it evaluates the promise. I went through the GraphQL code, and there are a lot of places where it's like, if the resolver returns a promise, then await something, something. Otherwise, something, something. There's a lot of branches like that, and I understand why. It's because promises are super expensive. You don't want to use them, and you don't want to treat promises and primordials the same way. That's a bad idea. So that's why I wanted to point this out, even though I didn't really go into depth here. OK, upgrade packages. Yeah, hopefully people upstream have made some performance improvements, but you know, that's like, sure, when we get to it. And of course, do more than just, you know, pepper the thing with the same message like millions of times over. Just try to get like a more realistic feel for what's going on in prod and try to capture some of the traffic, at least the patterns, if not the data, and come up with a more realistic load test. And so that's something we're working on as a team. And that's not just me, because we want this for like many different reasons, not just for performance reasons. All right, so let's see. OK, insights that I had on this journey. OK, so choose carefully what you attach to your context. I think I drove that home pretty well. Like if it doesn't need to be there, it doesn't need to be there. If it does need to be there sometimes, then try to make it so that it's only there when it needs to be there and not at any other times. So, OK, execution efficiency and memory usage efficiency, they're not exactly orthogonal, because sometimes if you improve your execution, you may end up going down a path that creates fewer objects. And so it'll help maybe your memory usage efficiency. So they're not entirely orthogonal. OK, another one, Node Clinic. This one helped greatly. All those 3x's and 6x's that you saw, I was looking at Node Clinic quite often. I ran that thing that I told you with Kafka and all that, and I ran it with Node Clinic, and I saw very clearly in the flame graph, like, ooh, yeah, big plateau here. Maybe it shouldn't be there. So this is a great tool. Just type it into Google. The guy who wrote it is a great guy. So yeah, worth checking out. And of course, Chrome DevTools. I mean, yeah, this heap snapshots just make your life very, very easy. All right, that was it for me. So please, if you have any questions, go ahead. We have 5 minutes? No, 7 minutes. If not, I'm going to be here till Thursday. So if something pops into your mind later, I'm happy to help.
So you mentioned partway through there was a server, the backend was written, I think with what I would call like front-end leanings. So you had like a Babel transpilation step.
Yeah.
The lowest common denominator, right? Dropping into that. Is there a reason that you went down that path initially in terms of like, hey, we need all this additional transpilation to make our JavaScript like super simple on the server? Or is it more kind of like hardware faulted where it's like,
yeah,
everyone else is doing this, and so we're doing it on the back end?
Well, no. I think it kind of came in from the front end, because like we use those same steps in both cases, and we just have a different configuration file. And the front end was around long before Graph, and Graph just kind of evolved into this thing that was just an API and not like a bundle with components and stuff. And so it was kind of historic, but as a result, it inherited all the configuration from the front end. And so, you know, I came around and I said, whoa. You know, the front end has to cater to 1 million browsers, but the back end only has to cater to one node, right? So it doesn't make sense to do that. So, but it was historic.
And did any of these learnings propagate back up to the front end clients at all?
To be honest, the front end clients, they're nowhere near as busy as Graph. Because we don't have like a single page application. We have like several front end services that serve different routes, and so they're not that busy. Their biggest concern is CPU usage, not memory usage, you know. And the front ends, even like the front end servers, the things that sometimes server side render and serve, and other times they just don't do anything, even those sometimes talk to the graph. So sometimes the talking to the graph is part of the server side rendering. Sometimes it's coming straight from the client. So either way, graph is like the focal point of everything. So it needs to work extremely fast and efficiently. The front ends, they're meh. I mean, we're always like, okay, can we shave off another pod because nobody's really using this, that kind of thing. And we're like combining front ends, putting, because like we got 3 pods for this, 3 pods for that, and they're at like 20% CPU. So it's like, just move the routes. So that's basically where it came from, and that's kind of the direction we're heading in. It's just consolidation and improving the efficiency. All right, go ahead.
You mentioned using KCAD
Yeah.
to make 4,000 connections.
Oh, no, not for the connections. I made the connections with just like what was it, like no, just, hold on. Sorry, just simple like WebSocket client or something. Is this, oh, this isn't showing, is it? Graph, last bin, connect to subscriptions. This is called Apollo Link WS. Yes, that thing. But you got to make sure that you create a subscription client every time. Otherwise, it'll just create one socket and it'll multiplex all your WebSockets into one, or your connections into one. So, but I pretended that I'm 4,000 independent clients. And just here, so I was running into things like, not enough file descriptors and that kind of stuff. So, because I had to like set the U limit to like 65,000 on my laptop just to be able to really put the load there.
I recommend to look at K6. It does neat stuff like that.
K6?
Yeah, later.
Oh, is that for the Kafka side?
Yeah, well, you can do both. You can do WebSockets, Kafka connections, and
Oh.
page loads, underload, and all sorts of cool stuff.
Cool.
Later we'll look.
Yeah, for sure. Thank you. Okie dokie. 3 more minutes. If anybody, otherwise I'll close up shop and we can talk offline. Going once, since I'm at auction, right? Going twice, gone. Thanks.